Kirchhoff's current law, or KCL, states that the total current entering a node or junction is equal to that same current leaving the junction. Let's look into this further. The circle here represents the node, and we have currents I1, I2, and I3 entering the node, and currents I4 and I5 exiting the node. Because of KCL, we know that the sum of the currents going in is going to be equal to the sum of the currents coming out. That means we can write this as I1 plus I2 plus I3 is equal to I4 plus I5. Alternatively, you could write it as the sum of all currents is equal to 0, where any currents exiting the node are represented as negative quantities. Now we're going to see how KCL works in a circuit. In this example, we have to find the source current and I2, with I1 being provided to us. First, we need to find the total resistance. This can be done easily by combining R1 and R2 and adding it to the value of R3. That gives us a value of 944.44 ohms. Now, using Ohm's law, we can very easily find the source current. We do this by dividing the voltage by the total resistance, and that comes out to 12.706 milliamps. Now we can apply KCL. We know that the current in equals the current out, which means that 12.706 equals 5.674 plus I2. We can rewrite this to make I2 the subject, and have it equal 12.706 minus 5.647, giving us a final value for I2 of 7.059 milliamps. To verify that the values that we have calculated are correct, we just have to introduce some digital multimeters into the circuit and run the simulation. Here they've been set up to measure the current, and we can see that all three values are identical to what we have calculated, which validates the concept of KCL.